Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakimi bin Muhammad Zafridin. My matrix number is B0517110091. My supervisor is Dr. Muhammad Nazmin bin Maslan. Today I will present about my final year project 2, which is development of design optimization for chili picking robot. Problem statement 1. In chili paddy farming process, basically have done by people which have some limitation. Number 2. Labor costs have increased year by year in this sector. Number 3. Productivity cannot be maximized by the current worker. Objective. Aim of this project is to propose the design optimized of the chili paddy picking robot. There are two objectives needed to be achieved. One is to design the functional of chili paddy picking robot for the fabrication. Number two is to optimize and apply the engineering analysis of product design needed for the chili paddy picking robot. The scope of the project is to designing the chili paddy picking robot in the SolidWorks software and planning each assembly part in terms of fabrication, such as identification of the robot design in the agriculture sector, development of the new chili paddy picking robot design, provide safety features in the structure of design, guidance on the proper handling of the robot, provide proper design based on the initial ideas, sketches, and the list of components given. And the last one is planning each assembly part in terms of the fabrication. Methodology. First, I find the supervisor and submit the proposal. If accepted, I will do the design concept with three criteria. We have three criteria. First, easy build. Two, based on the idea initial sketches. And three, budget friendly. With that, I will do the concept evaluation and concept selection. And then I will get the detailed design. Detailed design, I will separate to the three, which is design, material, and ergonomic. And then I will evaluate it and analysis. If fail, I get back to the detailed design. If pass, I do the result. I can get the result and conclusion. And then I will done this project. Next is result and discussion. This is a view of the initial idea sketches, and I will do the new design based on this initial idea sketches. This is cross-section view for the initial idea sketches. This is the top view, and we will understand how this robot run, which the grabber grab the polybag and the delta arm, and gripper pick the chili and put it into the canister. Firstly, I do the design selection. I have made four design based on the initial ideas of design sketches and component given. This concept screening and scoring, I have applied to this for design to get the simple design and easy to build. This is the design selection. I have done the concept screening and concept scoring. At the left table, I do the concept screening. I list four type of design, and I list the selection criteria, which is toughness, ergonomic, mobile, stability, portable, design, safety, sustainability, easy to build, and the cost. And I evaluate this concept screening with the previous method and the previous method correlate with the ranking, parallel to the ranking, which is, as example, 1 equal to the symbol negative, negative, double negative, 2 same as negative, 3 same as 0, 4 same as plus or positive, 5 same as double positive. And I'll evaluate and put the value, sum of plus, sum of 0, and sum of negative, and I get the net score, and I rank the each design, and I will get who is the best, and I can combine the design to upgrade to the better design. And same as the concept scoring, which is I put the selection criteria, weight, concept A and D, which is I get from the concept screening. I combine the best two of the best value from the rank and combine it in the concept scoring, and I continue the design concept of B, and which is I get the highest percentage from the design concept A and D, and of course its rank is the number one, and I'll continue the design concept of A and D. This is the final design, and this is the list part by part. This is the exploded view for the final design. Material selection for the prototype fabrication. we use the CES EduPack 2013 software. We select the 5 material, which is stainless steel, zinc alloy, magnesium alloy, titanium alloy, and aluminum alloy, because the material characteristic in terms of toughness. And we can see from the data modulus young versus density, we can see the zinc alloy and the stainless steel, the density is higher, and magnesium alloy, the density is the lowest. For the young modulus, all of this material not so far from each other. For the second data collection, we can see price of the titanium alloy is the highest, and for the zinc alloy and aluminum alloy, the price is the lowest. For the titanium alloys, it is the highest yield strength. For the tensile strength versus fracture toughness, this is the data collection. We can see the titanium alloy is the highest tensile strength, and the highest fracture toughness is the stainless steel. On the right side table, this is the overall criteria and the material list, 5 list of the material and the data. We can see the lowest price, the material, which is aluminum alloy, and the highest material is the titanium alloy. I have done the ranking method based on the right side table, and I list the material, all of the material, and stainless steel have ranking the first one, and the last one is the magnesium alloys. But I choose aluminum alloy for the prototype fabrication because in terms of its density and its price. Aluminum alloy also available in form of aluminum profile that are easy to build and suitable for producing prototype robot. This is finished element analysis FEA on the gantry design, which is the aluminum profile 45 times 45 mm, aluminum alloy 6061. Total weight that apply the aluminum profile is 100 Newton. You can see on the maximum stress analysis, which is 1.297 exponent 1 Newton per mm square, and it is not it is below than yield strength. And then second feature is displacement analysis. This the maximum displacement is 4.392 exponent -1 mm. This is strain analysis. The maximum strain which is 1.484 exponent -4, and the next one is the factor of safety analysis. Maximum safety analysis of analysis is 1.55 exponent 4 for the factor of safety. The ideal value of the factor of safety is 1, but the material used is focused on the lightweight and low price, so that is the reasonable to accept. This is rapid upper line assessment or ruler. This is to evaluate the user posture, ergonomic risk factor. I compare between 165 cm and 185 cm height of a man and get the same result, which is 2. Final result is 2, and the score 2, which is the level of risk, negligible risk, and no action required. For the conclusion, the objective, which is to design functional of the chili padi picking robot for fabrication, achieved because one of the 4 designs have been made and selected using concept of cleaning and scoring. And the second objective is to optimize and apply the engineering analysis of product design needed for chili padi picking robot, where the design has been run in the simulation and resulting stress, strain, displacement, and factor safety, and the objective is achieved. For the others conclusion, can get knowledge on how to the design and to select the material for the design, and apply knowledge what I study. Recommendation: the deeper design can be upgraded again to get a better result when the robot pick the chili. And the second idea to reduce complexity is needed since the robot was first time built, and lifelong learning and basic entrepreneurship is needed. And this project can be reviewed for the next generation to continue the study this project. And the last one is sustainability. The part and the structure has been minimized and will produce the manufacturing waste for the metal type, and this material can be recycled and remanufactured for the other purpose. That's all from me. Thank you.